Hello friends, welcome back to sessions of Python based data science series. In today's session, we are going to discuss about recursion. Now, we already have a discussion about function. Now, function is a process which is defined outside the main process and which is defined for performing a specific task. Now, many times we need to either call a function from another's definition, or we need to set a physical loop at the time of recalling the processor. So here comes the new terminology called as recursion. Now first of all, we'll be going to understand what is recursion means. Recursion is a process where we can define and call a function from its own definitions. Reoccurrence, re-reference, this is actually the meaning of recursion. Recursion is the process of defining something in terms of itself. Means if you re-refer it from its own definitions, it become a recursion. A physical world example would be the place where two parallel mirrors facing each other. If you place two parallel mirrors facing each other, so any object comes in the between will be reflect recursively. Means like if you just place two mirrors like opposite to each other, what will happen? You will find the loop of that all the objects comes in the mid. It means what? That all the problems which we need to have a setup of a physical loop, instead of setting a physical loop by reoccurrencing, by calling that function again from its own definitions, we can have a setup of a loop again. Means by using recursion without using a physical loop, we can resolve that all the problems. We'll be discussing all these things when we discuss by the examples. So in simple terminology, what is recursion means? Reoccurrence, re-referral of the same functionality. As we understand that we can refer a functions from another's definition, right? We can refer the functions from another definitions, but if you re-refer the functions from its own definitions, it become a recurrence. It become a recursion. So let's understand this by one example. Let us say if you give a call to the functions called as recurse. Now the control will be transferred to its own definitions, and from its own definitions, if you repeatedly give a call to itself, obviously we need to set the finite loop over here. Why we need to understand the loop? What is loop means? There is a start point, there is a termination, and there is a step over there. So by referring to the example that when you place two mirrors opposite to each other, it forms the loop of the images. In the similar manner, whenever you refer a functions from its own definitions, it forms a loop. Now this loop is called as a logical loop, and that for loop, while loop is called as a physical loop over there. So I can explain in such a way that by using recursion, you are setting up the logical loop, right, rather than the physical loop over there. Means you can repeatedly execute the process till the terminations, and that is what the recursions, reoccurring a function, right? So obviously recursion having its own advantage. Okay, recursive function makes the code block clean and elegant. The complex task can broken down and into the simpler some problems using recursion. Sequence generation is easier with recursion that using same nested iterations. Means like it instead of lengthy code, right, instead of we can cut short it, okay, in a like the number of lines, and then the division of problems into the sub problems. Like if you divide a problem, divide a function into the various sub functions, then it become so many subparts over there, rather than it become easy for us to make a part of its own sort of. And the one advantage that, okay, instead of setting a physical loop, you can set a logical loop, just whenever you you try to understand the recursions, like okay, two mirrors are there, put opposite to each other, it forms a loop of all the images. So this is what I mean, the logical loop. So here, instead of setting that all the problems where we need to set up a physical loop, right, start point, terminations, and the incrementations, that all the problems we can resolve and solve by using recursions. Now obviously everything have its own advantages as well as disadvantages as well. So recursion also having disadvantages, because basically obviously the code become much more tougher to understand. Sometimes the logic behind recursion is hard to follow through, because as I said, okay, you are not referring the another branch, you are referring to itself. So code become it increase the code complexity. Recursive call are expensive, inefficient, as they take up a lot of memory and time. Obviously, as you are setting a loop over there is a stack will be formed, and more memory and time may be required over there, complexities may be generated over there. Recursion functions are hard to debug, obviously, as it is a shorter expressions, as it is developing a code complexity, sometimes it become hard to debug, but obviously it have a lot of advantage also available over there. So considering this, all the advantages of the recursions over there, it set up a logical loop to solve all those problems where we need a physical loop to be set over here. Reoccurrence of a functions from its own definitions called as recursions. Let us go for the examples of the recursions using Python. Python test, and I am having a folder called as recursions where I kept my test code, and you can use code dot to launch your Visual Studio Code. Here is your first example, factorial. As we already saw these examples of a factorial, now what is factorial? As we all know that we need to set a physical loop where the value of n, which factorial you are finding, you have to reduce 1 by 1 till 1. So n factorial equals to n into n minus 1 into n minus 2 till 1. So there is a loop of decrementing the value of n till 1. So without using, in normal factorial functions, without setup of a physical loop, which decrements value of number to 1, you cannot solve the problem of factorial. Factorial is a matter of holding the multiples of it. Let us remove this physical loop and form a logical loop of calling or of referring the functions from its own definitions, and by using recursions try to solve this problem over here, right? So here I define the factorial function num. Now as we are going to set up a loop over there, we need to think about the terminations. If num, the value of number, is a function definitions what we are referring to. If the value of num become 1, return 1, right? It become a terminations. If the value of num become 1, return 1, else return num into factorial of num minus 1. Means here the number into, you are re-referring it again, right? So this is what recursions means. Here you will not find any physical loop, right, which decrements the value of number to 1. Here we refer that functions by the updated arguments num minus 1. So here the num equal to 5, and a factorial of number is, and here we give a first call. Okay, so number will initialize to 5, means we want to find out the factorial of a 5, and here it gives you a first call. So value of number is 5 now, right? So if num equals to 1, no, right now the value of num is 5, so it comes to the else block. So 5 into, it again branch the give a call to the factorial. Now 5 into 4 into 3 into 2 into, in this manner it will recursively give a call to, and it generates the stack. 5 into, the expression is not completed, then 4 into, if the expression is not completed, 3 into, that factorial will again give a call when the value of when it last get a call to factorial and the value of num is 1, the return 1. Now the reoccurrence of that factorial functions get terminated. Okay, so return once, the last call means that 2 into 1, now it become a complete statement. So 2 into 1 is 2, so it is returning into 3, 3 into 2 is 6, right? Means like, and 6 into 4 is 6 into 4 24, and 24 into 5 is 120. So here how it gets a call. Let us make a multi-line comment here. Initially when num get a call, that is 5 into, okay, and then here num minus 1, it again give a call to, okay, so then it become another expressions 4 into, then 3 into, then 2 into, and then when the value of num become 1, it returns. So it returns means now the next call will be terminated. So now 2 into 1 is 2, so this 2 value will be returned over here. 3 into 2 becomes 6, and 6 returns over here. 6 into 4 is 24, 24 returns over here, and 24 into 5, that is 120, and 120 will be returned to the calling area, right? So in this manner, the factorial of 5 will be written the 120 over here, right? So this is again, this simple examples gives us the idea. Okay, if you set up two mirrors in front of each other, then it forms the loop sort of. So by referring a function itself from its own definitions, by changing number of arguments, we can have a logical setup of a loop, and then we can solve all the, just like as I explained you the example of factorial. Without setup of a physical loop which decrements the value of n to 1, you cannot resolve the problem of factorial. But here in this case, without setup of a physical loop, we set up a loop of a recursive call of the same function, and in this way we can resolve the problem of factorial. So this is the best example of the factorial over here. Factorial. Let us run this code and test it. Here it is, the factorial of 5 is 120. You can give any value of number, or even you can modify it to ask the user to enter the value. Let's do it. You define man, okay, and num equals to integer of input, enter a number, and then that value will be held in the number, and then you can print the factorial number, so and so. And then here if name equals to man, call to man, just run it again. Just what else? Okay, check the spell of input, that is input. Here it is, enter a number. If you enter 4, it's 24, right? And if you enter 5, 120. So in this manner, by using recursive factorial, you can able to find out the factorial of any given number. Let us go to the next question. Now we need to try all the examples by using recursions, because as I already explained you that all the problems where we need a physical loop need to be set, but by using recursion, by giving call to the same functions from its own definitions, by changing the number of arguments, right, you can able to resolve that all the problems. Now let us, you have a question that you have to read a number and find out the 10 multiples of it. As we know that finding the 10 multiples means you have to set the loop from 1 to 10, and that incremented counter you have to increment the number. So we already tried that problem in the while discussing functions, but now let's like set up a target that okay, how we can find out the 10 multiples of a given number by using recursions. So here what we did, here enter a number for the 10 multiples. So you develop a function called as recursive function called as multi, where we have a n as a number and the 10 as a number of multiples required, because here you need a termination also. So here n and x, here initially let us understand you want to have a 10 multiples of a 5. So you n value is 5 and x is 10. If x equal to 0, because obviously your 10 multiples are there, so there is a terminations. Okay, so if x equal to 0, return means you have to break the control over here. Otherwise print n into 11 minus x means like as you know the value of 10 multiples you need over there. So for it has to grow like n into 1, n into 2, right? So as you pass on 10, 11 minus x means now it is 10. So it will print the 1 first multiple, and n into 11 minus 10, that is 1. Now x minus equals to 1, you reduce the value of x by 1, so 10 becomes 9. 11 minus, now try and understand, you have to generate the numbers like 1 to 10, and you have 10 given over there. So why not you 11 minus 10, that is 1, 11 minus 9, that is 2, 11 minus 8, that is 3. In this manner you can also generate the numbers, and the multiplication can be like, because whenever you give a call to the multi, why you need 2 arguments, because you should have a terminations, and you are not setting a loop over here. So multi I am giving call to, n is the number which multiples I want to find, and 10 is a number of terms, multiple terms I required. So if x equal to 0, return, it terminates the loop, and then here n into 11 minus x and n into 11 minus x means in this manner the multiples will be printed, and x you are minus, and giving call to n again. So now here initially n and 10, then next will be n and 9, then n and 8, means in this manner the value of x is continuously updating from 10 to 1, and once x becomes 0 it terminates. And in the meantime, okay, 11 minus 10, 11 minus 9, 11 minus 8, in this manner 1, 2, 3, 4 that values are generating, and you are continuously multiplying it by n. So you can able to find out the multiples of 10 multiples of any given number from 1 to 10, right? Hope you understand it. Referring a function from its own definition and formation of a logical loop rather than the physical loop. So in this manner recursion occurs, right? So this is the recursive definition of a multifunctions. Let's go for the execution. Enter any number to find the multiples. Let's say I want to find the 10 multiples of 5, so I input 5. So here is the 10 multiples of 5. If you want 10 multiples of Python, that multi py, enter a number of multiples is 6. So here the 10 multiples of a 6 over here. So we successfully able to generate a recursive function for finding multiples of any given number. Again, the key factors are there is no loop exists, only the loop exists of a function call. There is a termination, there is a initial call, and there is a step value. So by setting up these all the three things which is required for the physical loop, but logically here you are referring the same functions from its own definitions, and in this manner by using recursions you can recursive functions you can solve out all the problems related to the continuity and series where a physical loop is required over there. Let's go for the next question now. Now let us generate, as we know, the Fibonacci series. Fibonacci series means addition of previous two terms equals to current term. What is the sequence? Okay, we have to add the two terms, first term and second term, to form the resultant term, and then swap them. First term becomes second term and second term becomes first term. That the logic we already know. Now how we can solve by using recursion? So here in the main we are inputting the first term, second term and total term, and I'm passing it on this first term, second term and total term as an argument to the function called as Fibo. And here Fibo is not a normal function, it's a recursive function. So here first term, second term, total term it will get. So as we have to print the first term and second term are user defined now here, not zeros and one now. So it's a first term and second term we already printed, and total terms minus 2, total terms minus 2. Okay, so we have to print because two terms of a Fibonacci series we already printed over here. So here if the total terms become 2, so return, because total term we are reducing one by one now. So you cannot like write termination total term equal to 0 because two terms we already printed. That's why if total terms equals to return terminations, resultant term equal to first term plus second term, we are generating that first term plus second term addition, and then we print. We already discussed about end blank space means we are printing everything on a single line. Otherwise every print will generate, every print will print the output in the new line. So instead of new line, if you want to concat everything in a one row, so that all the Fibonacci series terms we are printing in a one row, that's why end blank space. So here we firstly first term and second term we already printed till the total term become 2. Okay, if the total term become 2, return y2. As I already explained, the already two terms from the total terms already we printed. Now we have to start from the third term. So third term will be first term plus second term. You print the resultant term and swap them. First term becomes second term and second term become resultant term, and then minus 1 from the total terms. As discussed in the last session that tt minus is not allowed in Python. You have to go with the tt minus equal to 1. So you have to reduce 1 from the tt, and then you refer back again the Fibo, the first term and second term, the updated first term, second term, and the tt again you pass on. So till the value of tt becomes 2, it continuously gives a call to the Fibonacci series, Fibo function, and it generates the Fibonacci series. Hope you understand the logic. Let's go for the execution. If I am having a first term as a 2, second term as a 3, and in this manner I need 10 terms. So look at this: 2 3 5, 5 3 8, 8 5 13 means addition of previous two terms equals to current term. In this manner 10 terms of a Fibonacci series are generated. So here instead of like assuming 0 and 1 are the first terms, I ask the user to enter the initial terms as well as total number of terms of a Fibonacci series, and by using recursive Fibonacci series we can able to generate the Fibonacci series of a user defined terms. Now let's go for the next. Now here is an agenda where I want I want to generate all the even numbers in the range of 0 to 100 and find their final summation as well. What is the task? To generate all the even numbers, because I want to demonstrate the recursions, as I already explained you, that all the problems where you need to set up a physical loop, all the problems related to continuity and series, where there is a continuous incrementation or continuous decrementations, we need to set up a physical loop. That all the problems we can able to resolve, we can able to solve by using recursions over there. Let us go for it. Now I want to generate all the even numbers in the range 0 to 100 and find out their summation as well. So here initially n equal to 0, sum equal to 0. I am having a function called as even sum, recursive function. So n value is 0 and sum value is 0. Here initially n is 0 and sum is 0. Obviously I need to generate, I need to increment the number till 100. So if the value of n more than 100, print summation. It has to print the summation and return, means terminate the things over there. So at the end of that, all generating all the even numbers, I will print the summation and terminate. Return means terminate the return back the control. So it terminate the process of that stack calling. And then print 10. Here initially n, the value of n is 0, so it is not more than 100. So print 10 means 0, and 0 will be added, and then n plus equal to 2. You are incrementing the value of n by 2, so n become 2 now, and again give a call to and pass on the sum over here. So here continuously the value of n is going to increment by 2 every time, and that updated value will be added to the sum. When the value of n become more than 100, then it print the summation and terminate, right? So in this manner, by using recursive even sum, we can able to generate all the even numbers. Okay, the logic of even number is n plus equal to 2, we start with the 0, and if you increment a number by 2, so obviously every even numbers will be generated over there, and then if you are adding those all the even numbers to the summation, and finally you print the sum, right? Let us go for the execution. Here it is. It generates 0, 2, 4, 6, all the even numbers in the range 0 to 100, and finally summation is 2550. It is printed. So the agenda for today's discussion is to discuss about the recursions. What we understand that recursions means repeated call, reoccurrence means instead of developing a complexible nesting of functions where you can call from main you call a function called as a, from a you call a function called as b or c and d. You can call a functions from any other's definitions, but can you not able to call a functions from its own definitions? So answer is yes, you can able to call a functions from its own definitions, and it become a recursion. Recursion having its own advantages. The lengthy code become shorter. You can various subtasks you can break up into small tasks, right? So we can shrink the code, easy to develop the code. So these kind of advantages are there. There are some disadvantages like, okay, debugging become tough, at the same time more memory and time required sometimes, okay, because of the stack formation and all that, all are there. But at the same time it's a good way to if you have a, as I said, if you have a problems related to the sequence and series where you need to have a physical setup of a loop, there is a continuous increment, there is a continuous decrement or start value and stop value. This way that like the programs we tried of a factorial, the Fibonacci, the even number generations, the multiplications, there you need to have a physical setup of a loop. So instead of physical setup of a loop, you can have a logical setup of a loop. Logical setup of a loop means just refer back again the same examples. When you put the two mirrors in front of each other, there is no loop, okay, but whenever you place a two mirrors in front of each other, what you will find, any objects in the between will be recursively forms recursively appears, and hence it become a recursions. So recursion is also another technique by which if you refer a functions from its own definition. Let us understand, if you call a main from main, what will happen? It will form an infinite loop, right? So in the similar manner, to make it finite now, okay, so we can have a call from the main, and then when it go to the function definition, we can think about termination, we can think about a step value. So in this manner we can make a finite setup of a loop instead of physically have a loop. So that is what exactly recursion means. So hope you I'm just like passing it on this all the tested codes which I'm demonstrating in these video sessions, so that you can test it with the compiler and understand the recursions. All the best.